changing stuff. This is all things that you're used to. Maybe the only added extra is the showing the result on a number line, but you've all just said you recognise that, yeah? Okay. Does anyone know already what an inequality is? No? Okay, so if I show you, you'll probably go, oh yeah. So, an inequality, right? An inequality looks like this.
The alligator now.
The alligators. Remember it?
So right.
It's an inequality because it's not equal to. In that case, it's actually, how would I write that in words?
Is that the thing where you have the dot and then you line?
How would I write this in words?
Less than.
X is
Greater than
greater than 5.
Is it like when it's equal to, if the line is circled, like filled in?
Yeah. Remind me. So this will be quick then. What if I were to write X is X is less than or equal to -3. Okay. Now, if I were to show these two on number lines,
I remember this. And it's like belonging to a dot colored in.
okay, so I've got to show that X is greater than 5. Now, give me a number where X is greater than 5. 6, 7, 8. How many numbers are greater than 5? A lot. An infinite amount. How many numbers are less than or equal to -3?
No.
Yeah? An infinite number. Okay, so we've got to show this on a number line. And why I say don't worry about showing other numbers is because we only really need to know the numbers that matter. In this case, it's 5. And I've got to do X is greater than 5. So I'm going to put a little mark here for 5. And I'm going to put a dot. But you guys,
fill it in.
right, is it filled or is it not
It's
filled?
not filled. So
Not-
that means it's equal to.
Yeah, so it's just an open dot, okay? So I put an open dot above the 5, and then I put an arrow going in the correct way. So that would suggest that X is allowed to be anything greater than 5. Right. What about the X is less than or equal to -3? Which end of my line would I write my -3?
The other side.
The other end. Because I'm going to, which way would the arrow be pointing?
That way.
That way. So I'm going to write my -3 up here. Dot filled or not filled?
Filled.
Filled in. Is everyone okay? Why?
Yeah.
We'll put a dot up. Right. I'll extend it a little bit further than maybe I thought I would do. So what if I were to do X
And then
So you have to find it.
so
-2 is less than X, but is less than or equal to 7.
no, it's X is.
I think she's right.
I thought it would be X.
She just said it in a complicated way. I would always start with X and just say X is what are you
More
going to
than minus
say? More than -2.
2, but less than or equal to 7.
Exactly.
Numbers.
So it's just easier. What you said wasn't wrong. It's just difficult to understand. So we just start with the X. X is basically between -2 and 7, including 7. So we would say X is greater than -2, but less than or equal to 7. Okay, shall I write that? So X is greater than -2, but less than or equal to 7. So we can now put that on a number line. I'm sure you probably know how to do it already. Now again, scale doesn't matter. We don't have to worry about how many squares there are. We just have to worry about the two numbers.
Can I count the AC?
Yeah. So I would put the numbers -2 and 7. It doesn't matter about how wide they are. Not counting squares, don't care. Just got to show quick diagram. That's why it's easier if you don't bother filling in all the other numbers. Makes it easier. And then what are my dots like?
That's empty and then 7.
So we've got an open dot.
Empty and then 7 straight in.
This one's a filled dot. And then we join with a line.
Does line have to be there, or can it be on the actual line?
I would say it needs to be above, because to show that there is a line there. Because do you remember the first one we did? It's only one dot. How do I know there's no? I guess I could write an arrow. But what if I were to just write this? That could just mean 3 and 7 only. So how would I know if there's a line there or not? So when there is a line joining the two, we put it above. Yeah, I'll just put it down. Right, what we're going to do is we're now going to move it on a step. We're going to say solve the inequality, right, and show the answer on a number line. Okay. So I'm going to give you this question. Solve the inequality. So I'm going to say 3x minus 4 equals 14. No, so I'm going to change that. Here's my tip for you. The equals isn't going to be equals. It's going to be one of these. Okay? And inequalities. So, how would I say that? What would I say? So you got the whole x is less than 5 or whatever like that. So what would this mean?
That whatever 3x minus 4 is less than 14. So the answer
Must be less
than 14.
than 14. So whatever x is, if I do 3 times that number and then minus 4, I must have an answer less than 14. How many possible x values are there?
A lot.
A lot. How many?
3.
Infinite again, right? There's an infinite. Did you say 3? Infinite number of solutions to this. Pick a value just off the top of your head that will work.
7.
7. 3 times 7 is?
14.
21.
21. 21 minus 4?
18.
Oh, so that's not less than 14. You're
17.
lying. Pick a value for x that actually works.
21.
You can use
3 times 21,
You can
Yeah.
use 4.
Not 10.
because 3 times 21 is
You
63.
could do 3 times
2.
4.
Okay, 3 times 4 is
12.
12 minus 4 is
8.
okay. So I could, don't write this down by the way, I could write, well, x is 4. That's a possible answer. Any other answers it could be?
2.
X equals 2 might work, because 3 times 2 is 6.
X equals 1.
What's the biggest number that would work?
5.
5, you think? X equals 5. 15 minus 4 is
11.
11. Is there anything else?
No, you
What about
can't
x
do
equals 6?
18 and then 1.
18. Yeah, no.
No, because it's not equal to 14.
Okay, so what would be the largest possible number? X
Five.
equals 6. 5, you think, would be
Yeah.
the largest. Okay, what about 5.5?
No, because then.
We learned this, but I don't remember what the
3 times 5.
Because you can only go up to like something like 5.8 or 9.
Well, actually, you could go 5.99999 forever, right? Therefore, we can't really write that. So, what we do is this. So, you've kind of done that in your heads. But what we do is this. I'm going to pretend I have an equal sign. And I'm going to solve the equality, because that will tell me the barrier, the limit. Okay? You can all do that. What do I do? So,
3x.
add 4. Yeah?
3x equals 14 plus 4, which is 18, and then x equals 18 divided by 3, which is 6.
So x equals 6. And then what you do is, instead of the equals, you put the sign back in.
Oh, we learned this.
Okay?
We
But then
learned
what I
this.
have to do is check that if I pick a value for x that's less than 6, I do get an answer less than 14.
Right, which will
Which
mean
we've
that you
already
can't
done.
do 6, which is your barrier is 5 or 5.9.
Exactly, so by saying x is less than 6, we can go for anything less than 6. There's no goal of decimals and everything. Does that make sense?
Yeah.
So you're using the same skills, but instead of that, instead of the equal sign, we just leave this sign.
We learned this last year.
Oh, good. I picked it because I thought I'll check, because it's the same skills that we've done together. If you've done it, we'll move on.
Do we have to do our number line then?
Yeah. So
Oh, yeah.
how do we do that on the number line?
It would just be 6 with the area.
Yeah, exactly. Just put 6. Which way does the arrow go? What's my dot?
It's like not.
Less than, so it's open or closed?
Normal.
Open.
Circle.
Just a circle, open, and the arrow goes in the less than direction. Okay. So there it is on the number line. Okay.
Can we do work here on this?